Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the today's question. This question is based on the topic of straight lines. It's an interesting problem. It says, let m1, m2 be the slopes of two adjacent sides of a square of side A such that a square plus 11a plus 3 times inside the bracket m1 square plus m2 square bracket close equal to 220. If one vertex of the square is 10 times inside the bracket cos alpha minus sin alpha, comma 10 times inside the bracket sin alpha plus cos alpha, where alpha belongs to open interval 0 to pi by 2, and the equation of one diagonal is x into inside the bracket cos alpha minus sin alpha plus y into inside the bracket cos alpha plus sin alpha equal to 10, then 72 into inside the bracket sin alpha power 4 plus cos alpha power 4 bracket close plus a square minus 3a plus 13 is equal to. Now students, in this problem we have been given a square of side length a units. Now I am calling this square as square ABCD with the length of each of its sides as a. Now I am assuming the diagonals equation which is given to us as the equation of the diagonal BD. You can also take it to be AC. It does not matter here. Now we have been given one vertex of this square and the coordinates are in front of you. Now first of all we will check whether this vertex lies on the given diagonal or not. And for that purpose we will just substitute the coordinates of the vertex in the equation of the diagonal. Now when we put x as 10 times cos alpha minus sin alpha and y as 10 times sin alpha plus cos alpha in this equation, in the left hand side we will get 10 into cos alpha minus sin alpha whole square plus 10 into cos alpha plus sin alpha whole square. Now students, just expand it and solve it. It becomes 10 times inside the bracket you will get 2 times cos square alpha plus sin square alpha. Because when you expand you will get minus 2 sin alpha cos alpha and 2 sin alpha cos alpha with plus sign also, but they will get cancelled. So ultimately you will be getting 20 into cos square alpha plus sin square alpha, which is just 1. So this becomes 20 and this is not equal to 10. That means it is not equal to RHS. So hence I can conclude that given vertex does not lie on the given diagonal. Right? So if I am assuming the diagonal as BD, then the vertex can be either A or C. So now I am taking this given vertex to be A. Right? Now students, we move further. Now students, we will find the perpendicular distance of the vertex A from the diagonal BD. That means the length of perpendicular AO. Now the coordinates of A are 10 times cos alpha minus sin alpha, comma 10 times sin alpha plus cos alpha. And to find the perpendicular distance of A from the diagonal BD, I will use the formula mod of ax1 plus by1 plus c upon square root of a square plus b square, which we use to find the perpendicular distance of the point from the given straight line. Right? Now the equation of BD we have as x into cos alpha minus sin alpha inside the bracket plus y into inside the bracket we have cos alpha plus sin alpha equal to 10. Now just use the formula. So from here you will get the length of AO as mod of 10 times cos alpha minus sin alpha whole square plus 10 times cos alpha plus sin alpha whole square minus 10 whole divided upon square root of cos alpha minus sin alpha whole square plus cos alpha plus sin alpha whole square. Clear? Now students, just simplify it. You will get AO as, in the numerator you will get 10 times 2 into cos square alpha plus sin square alpha inside the bracket, and then we have minus 10, and in the denominator just apply the identity a minus b whole square plus a plus b whole square. So it becomes 2 times a square plus b square, which becomes 2 times cos square alpha plus sin square alpha. And we know that cos square alpha plus sin square alpha is just 1. So finally, the value of AO comes as 20 minus 10. It is 10 divided upon root 2. Now students, we move further. Now students, we know that AO is half the length of diagonal of square ABCD. And we also know that if a square has side length A, then the length of its diagonal is root 2 into A. So that means AO becomes A upon root 2. But we have already found the value of AO as 10 upon root 2. So this means A is equal to 10. Now students, we have been given the equation A square plus 11A plus 3 times M1 square plus M2 square equal to 220. Now just substitute the value of A in this equation. So it becomes 100 plus 110, which is 210 plus 3 times. Now students, M1 and M2 represent the slopes of two adjacent sides of the square ABCD. And we know that any two adjacent sides of the square are perpendicular. So I can say M1 into M2 will be equal to minus 1. Right? So in place of M2, just put minus 1 upon M1. Now it becomes inside the bracket M1 square plus 1 upon M1 square. Now just simplify this equation. It becomes 3 times M1 square plus 1 upon M1 square equal to 10. Now it further becomes 3 times M1 to the power 4 plus 1 equal to 10 M1 square. Now students, just put M1 square equal to T. Now this equation gets converted into a quadratic equation in terms of T. And that is 3 times T square plus 1 equal to 10T. Now just solve this equation to get the value of T and hence the value of M1. Now it becomes 3T square minus 10T plus 3 equal to 0. And factors of this equation are 3T minus 1 into T minus 3. So from here we get the values of T as 3 or 1 upon 3. So that means either M1 square is equal to 3 or M1 square is equal to 1 upon 3. Now we move further. Now students, since M1 and M2 represent the slope of two adjacent sides of the square ABCD, so I am considering slope of AB as M1 and slope of BC as M2. And slope of diagonal BD we can easily find because we have its equation, and it is minus inside the bracket cos alpha minus sin alpha divided upon cos alpha plus sin alpha. Now students, to simplify this expression, just divide up and down by cos alpha. So now it becomes minus inside the bracket 1 minus tan alpha divided upon 1 plus tan alpha. Now in the denominator, rewrite this tan alpha as tan alpha into 1. Now students, if I replace this one and this one by tan pi by 4, now it will take the shape of a trigonometric identity. In the numerator, it becomes minus inside the bracket tan pi by 4 minus tan alpha, and in the denominator, it becomes 1 plus tan pi by 4 into tan alpha. So now finally, it becomes minus tan of pi by 4 minus alpha. I have just applied the identity of tan A minus B. Now students, we know that in a square ABCD, the diagonal BD makes 45-degree angle with any of its sides. That means the angle made between the side AB and diagonal BD is 45 degree. And we also know that if there are two lines with slopes K1 and K2 and making angle theta between them, then mod of K1 minus K2 upon 1 plus K1 K2 is equal to tan theta. Now we will just apply this formula on the lines AB and BD. So I can write M1 plus tan of pi by 4 minus alpha divided upon 1 minus M1 into tan of pi by 4 minus alpha equal to plus minus 1. Right? Now students, I will discuss both the cases. First case is when M1 plus tan pi by 4 minus alpha is equal to 1 minus M1 into tan pi by 4 minus alpha. That is on the right hand side I have considered 1. Now students, just get the value of M1 in terms of alpha. So now it becomes M1 into inside the bracket 1 plus tan pi by 4 minus alpha, and on the right hand side we get 1 minus tan of pi by 4 minus alpha. Now we move further. Now students, we know that 1 minus tan theta upon 1 plus tan theta can be written as tan of pi by 4 minus theta. So that means M1 becomes tan of pi by 4 minus inside the bracket pi by 4 minus alpha. So now this becomes just tan alpha. And now if I consider the second case for that equation, that means on the right hand side, if I take minus 1, then the value of M1 becomes minus inside the bracket 1 plus tan of pi by 4 minus alpha divided upon 1 minus tan of pi by 4 minus alpha. Now students, we know that 1 plus tan theta upon 1 minus tan theta can be written as tan of pi by 4 plus theta. So now this becomes minus tan of pi by 4 plus pi by 4 minus alpha. And this is how much? This is minus tan of pi by 2 minus alpha, or this is just minus cot alpha. Right? Now students, we have two values possible for M1. One is tan alpha and another is minus cot alpha. And you know that M1 and M2 are just negative reciprocals of each other. So that means if I take M1 as tan alpha, then M2 will be minus cot alpha. And if I take M1 as minus cot alpha, then M2 will be tan alpha. Right? Now students, earlier in the question, we found the values of M1 square as 3 or 1 upon 3. And here also, if I take M1 square as 3, then the value of M2 square will become 1 upon 3. And if I take M1 square as 1 upon 3, then the value of M2 square will become 3. Fine. Now students, from here, we can finally conclude that there are only two possible values for tan square alpha, and they are 3 or 1 upon 3. And now to evaluate that expression, we need to find the value of sin alpha power 4 plus cos alpha power 4. Now sin alpha power 4 can be written as 1 upon cosecant alpha power 4. And we know that cosecant square alpha is nothing but 1 plus cot square alpha. So I can write this as 1 upon 1 plus cot square alpha whole square. And cos alpha power 4 can be written as 1 upon secant alpha power 4. And we know that secant square alpha is 1 plus tan square alpha. So now it becomes 1 upon 1 plus tan square alpha whole square. Now students, it's very easy to find the value of this expression because we already know the value of tan square alpha. So now we move further. Now students, you can clearly notice that the value of sin alpha power 4 plus cos alpha power 4 will remain same in both the cases, whether you take tan square alpha as 3 or 1 upon 3. Now if I take tan square alpha equal to 3, then the value of sin alpha power 4 plus cos alpha power 4 is equal to, now it is 1 upon 1 plus tan square alpha whole square. So this becomes 1 upon 4 square or 1 upon 16 plus 1 upon 1 plus cot square alpha whole square. So this becomes 1 plus 1 upon 3 whole square. Or this becomes 1 upon 16 plus 9 upon 16. And this is 10 upon 16. Finally, this is 5 upon 8. Now, if I take tan square alpha equal to 1 upon 3, then the value of sin alpha power 4 plus cos alpha power 4 becomes 1 upon 1 plus 1 by 3 whole square plus 1 upon 16. And this becomes 9 upon 16 plus 1 upon 16, or again 5 upon 8. Now students, we have to calculate the required expression, and it is 72 times sin alpha power 4 plus cos alpha power 4 plus a square minus 3a plus 30. Now just put the values. It becomes 72 into 5 upon 8 plus 100 minus 30 plus 30. Now it becomes 45 plus 100, that is 145 minus 30 plus 13. So finally it becomes 128. So that means option B is the correct one. Now students, next question I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.